back, we're doing example 4 from section 1.6, our foundations for geometry, and we are setting some really good foundations. Now we're going to talk about the Pythagorean theorem. This is something that you definitely want to add to your electronic notebook. We've been working previously with postulates, now we're working with a theorem. Theorems are just a little bit stronger than postulates. They've never been disproven, so this is something we accept as truth, and that the numbers verify the veracity of the theorem. So anytime you have a right triangle, if you square each of the legs and add them together, that equals the square of the hypotenuse. Okay, let me go up to the board and let's talk about the anatomy of a right triangle really quick. Okay, I think I've emphasized this in algebra, so hopefully this will be a quick adventure. The hypotenuse is always your longest side. Okay, longest side is always going to be your hypotenuse. And we always label the hypotenuse C. Always, 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 always. There is not a time that you would ever label the hypotenuse A or B. If you do, you're going to calculate your triangle incorrectly. Now your legs can be labeled either A or B. It doesn't matter. Okay? So if you do a squared plus b squared equals c squared, and you're trying to find one of those missing sides, you can find it. If you know the other two, you can find that one. Now I want to show you the relationship between the distance formula and the Pythagorean theorem, because you can use either one to calculate it. Okay? So we're going to use both the distance formula and the Pythagorean theorem to find the distance of AB, and we're going to round our answer. So we're going to get a square root, but we're going to put it in our calculator and round that answer to the nearest tenth and compare the answers. Okay? Now, ideally, if you're doing it right, it shouldn't matter which method you use. If you use the distance formula or use the Pythagorean theorem, it shouldn't matter, because you should get the same exact answer. If you don't, you did something mathematically incorrect. Okay? So we're going to let this one be the distance formula, and that's where I'm going to start today. So we're going to try and find the distance of AB, and A is -2, 3, and B is 2, -2. So we're going to go back to that formula. Remember, we have to subtract our x's. So -2 minus 2. Okay, that's -4. So we're going to end up with -4 squared. And we're going to do the same thing with our y's. 3 minus a -2, which is going to be 5. Okay, so we're going to end up with -4 squared is 16, 5 squared is 25, and it looks like 16 and 25 is going to net us a square root of 41. Put that in your calculator, and you'll get approximately 6.4. Okay, now notice I used the squiggles, the double squiggles again, because if anytime you have to round your answer, then that's 6.4 isn't the answer. 6.4 is very, 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 very close to the answer. Okay, so I just want to make sure I emphasize that again to you. All right, now we're going to do the Pythagorean theorem, and in order to do that, we're going to have the segment AB, that's going to end up being our hypotenuse. And we're going to drop a vertical line straight down. We're going to call that B. And then we're going to do a horizontal line that connects the B over to the other endpoint. Okay? And we'll label that A. And so we're going to use A squared plus B squared equals C squared. And C squared is our hypotenuse. C squared is segment AB that we don't know. And so we're going to count the number of boxes, okay? So to count the length. So there's 1, 2, 3, 4, 5. So it looks like B, length B, when you drop a vertical line down from endpoint A, it looks like it's 5 units long. Okay? And then let's do the vertical or the horizontal distance. We've got 1, 2, 3, looks like it's 4 units across. Okay, everybody catch that? So going down it was 5 units, going across it was 4 units. And then let's square those. Adding together. Sorry about the messiness. Now I'm not looking for c squared, I just want to know the length of that segment, which is just c, so you're going to have to take the square root of each side. So we have c equals the square root of 41, which is again approximately the decimal, if you round to the 10th, 6.4. So I've just shown you 2 methods you could employ. You could just do the distance formula, or you could create a right triangle and use the Pythagorean theorem to help you find the length of that segment. So it's really up to you to decide how you want to tackle that and how you want to do that. Okay? So any questions for me, write them down. Let's practice this in class tomorrow.